Once again, the way a computer works perfectly demonstrates how this could also work in physics. How do you imagine the algorithm for generating a neural image? If you read about how it's set up, by the way, I could be mistaken here as well, so keep that in mind. But this is how I understand it. There is a certain set of digital noise. This set of digital noise creates a working area. This working area follows mathematical rules. It's not just random noise. Digital noise can be understood as a kind of chaos. Then, pass by pass, using specific points and concepts as reference, the outlines of the future image begin to emerge within this noise. One pass is made, and on this digital noise, the points where objects should theoretically be are marked. These objects don't just appear out of nowhere. At some point, the neural network created a set of directives for itself, and it pays attention to these directives. In other words, a dog, for the network, is a set of points that follow certain specific equations, certain patterns. So when we ask it to generate an image of a dog, the neural network places points in different locations. These points have mathematical coordinates, and moreover, each dog will look a little bit like another dog. This is the foundation of the neural network's design pattern. When we analyze several images of the same object in different poses, views, and so on, we find certain mathematical patterns. What is the strength of neural networks today? It's that before, we could generate a dog automatically, but now neural networks can determine this on their own. The algorithm is built in such a way that it runs through this set of points and analyzes that for a dog or for an object programmed to be a dog, there will always be a point in this place. So how is this related to chaos? So when we said that we have this digital noise from which points are selected, the neural network actually starts to draw new points step by step. And as a result, out of this chaos, we get a simplified phenomenon. What was the difficulty? The difficulty was that in the digital noise, which served as the initial material for the neural network, each point could have millions of parameters. But by using energy, spending electricity on it, which by the way is not cheap either, and putting in some effort for training by providing information to the neural network, if we speak in physical terms, we were able to tame this complexity. And as a result, the neural network gradually generates. So I look here, and somewhere in my portfolio of information, I have data that says this point should be gray, shifted like this, so let it be gray here. And with this kind of simplification, from a huge number of chaotic points, we created the image of a dog. And you could say that a physical system works in roughly the same way. When we talk about the formation of a crystal, we take a huge amount of information about this crystal and reduce it to something concrete. In physics, this is called the system's ability to self-organize.